everybody. My name is Joshua. I'm the Director of Technical Evangelism at PHALA Network. And today I'm going to go over PHALA Network's AI coprocessor and how we are the execution layer of the Web3 AI. So let's see if, it does work, cool. All right, so here's like a little overview. I'm going to go on a history run on PHALA Network, just kind of showing that we have a history of delivering products and why this history has kind of led us to get to the point where we believe we are becoming an AI coprocessor and we can really make a strong product in this market. Next, I'm going to go into PHALA's AI coprocessor, so kind of break down the high-level architecture of the coprocessor and introduce you to the programs that you can be able to build to deploy on PHALA called the AI agent contract. And next, I'll kind of get into the AI agent contract, which is going to enable you to build really quickly, and for now, without an account, without any crypto, you can deploy pretty much a fancy little HTTP server on our network and you can serve GET and POST requests. And then I'll show you our first product to experiment on monetizing these agents, these AI agents that are deployed on PHALA through our first product that's our true experiment with Agent Wars. And then after that, I'll kind of dive into what builders are actually building and something that we actually did last week at the DAGI Hacker House. And then finally, I'll kind of introduce what I call a pipe dream, but something that I'll define like a problem statement about the future dangers of centralized AI and offer a little bit of hope and see how we can solve this in time with TEs today. So just to go into the history, PHALA has been building since 2017. Our white paper came out in 2019, and our mainnet launch was at the end of 2021 and 2022 for our parachain on Kusama and on Polkadot. Luckily for us, we were able to bootstrap our protocol with over 30,000 nodes. So right now, I believe we're over 36,000 attested TE nodes on our network. And our first adventure was with what people know as a FAT contract, and that was a coprocessor for blockchain. So we believed that we could enhance your on-chain smart contracts with our secure off-chain computation protocol, where you could deploy a FAT contract and be able to make cross-chain calls and extend to external APIs so that you could have a data-driven application. So it was like one of the truly first hybrid chains that came to Polkadot in general. And then lastly, I'll show like some of our trials and efforts that ended up leading us to this AI coprocessor that we offer today with the AI agent contract. So just to kind of give you a little bit of proof, if you want to go on to analytics.phala.network, that's where we have all of our stats about the network. Here it shows 36,605 workers attested to our network. And if you go in there a little bit down, you'll see all the AI agent contracts that we have deployed on our network as well. So PHALA, yeah, as a coprocessor for blockchains, this is what we believed our mission statement was just whenever we first presented our FAT contracts products. We were able to connect to any blockchain, EVM, substrate-based, anyone that had a L1 Inc. smart contract as well. So we had all these solutions, and it was more of like an oracle that you could have that was programmable. And then also you had those security and confidentiality guarantees by default with the execution within the TEE. So if you have a little view of like what this process looks like, you can see that you have the FAT contract that's deployed on our network able to, one, start connecting to these external data sources, like say like an indexer from the graph or subsquid. And then you could do some like computational process over that, and then also generate a proof, like testing to the work that was been done, so that you can sign a transaction, attest to that transaction being done within the TEE, and then submit that back down to, say, like in this case, Ethereum on the EVM-based chain. So this kind of like led us to this solution where we weren't really getting too much adoption. It wasn't driving developers too crazy about it. So we did tend to see that there was a lot of ease with AI in general. So I'm sure like a lot of you have used AI in your current workflow, and it does really speed up some of the dirty work that you have to do, or some of the logic that you had to write and code really quickly. So like say that it just really speeds up the process, and we really believe that since we had this middleware sitting there, we could use AI in an intelligent way so that we could start building more intelligent applications on blockchain today. So as you can see here, we have this TE code processor. We can connect to different model APIs very easily. Say you built your own model that you trained and you want to interface with this with PHALA network. We can offer that secure end-to-end transfer of data so that you can build these more robust applications. We also have this thing that says TEML. I'll explain this a little bit later on some of the work that we proved out as a proof of concept as well. And then we also have a product called Red Pill. This is separate from PHALA, but we built pretty much a model aggregator and being able to tokenize the tokens for these models so that you can offer your API key and then also allow people to actually earn yield on that API key, and then have people get an API key for very cheap with a rate limit as well. So AI agent contract has two components, the agent DAO and the agent script. So what I'm gonna show you more and talk about more today is the agent script, which is pretty much running a backend on PHALA network. But you can think of it as the agent DAO regulates the agent scripts so that you can create these monetization aspects to your agents that is not present today. And it's really hard to monetize your agents, or you're stuck with a single model that a blockchain supports. And so I'll go next to give you a high-level diagram. So say like you have an EVM chain on an L2, and you want to deploy your application here. This is actually how the proof of concept that we built with Agent Wars, which is the ability to clone your Twitter profile and have a model that has done some in-context learning on that data, and then be able to chat with it with some expected responses based on how you post your tweets. So, for example, the incentivization part of it with the agent DAO is creating a bonding curve for these keys that you buy to interact with the agent, and then having unlimited chats with the agents as well. And so when it comes to the AI agent contract execution, so this is specific to the agent script. So the agent script, having your different prompt configurations, this is going to then be served through our gateway, agents.phala.network, and there's a /IPFS, and then you put your CID so that you can do a GET request or a POST request, however you would like, but then it gets served through the gateway and executes within this JS engine that we've embedded in our runtime that's executing in the TEE. And what we've enabled is up to 120 seconds of computation time. And you can get really creative here. So you can start connecting to other external data sources, other models, and start to build these robust agents that is really hard to do on-chain today. So this is just kind of the model of how this looks like. So you would compile your code with our CLI tool. You would then upload that to IPFS. And then we would serve it through our gateway, and then it would execute this JS program that's compiled down, and then you can start interacting with it through your GET and POST request. And you can add your custom logic there to however you want to route your calls and be able to get different answers based on the prompts from your users. So let's do a basic example. So this one was, I wanted to create a tool. This doesn't connect to an AI model, but it does utilize the ability that we have created to call a derivation key. So like you can derive a key within the TE and then pass in a secret, it can then create this public key. So in this case, here's my public key that was derived with my first GET request. And then I add some queries to then say, I want to sign a message that says, hello, moon. And then I get a signature back. So this is really small text. If you can't see, I'm sorry. But this is just how the process is working right here, because it's returning, in this case, I was just returning an HTML page, so I could just give a little fancy output with this template. And then I call another GET request, and I can validate that this signature is true by passing in the message, the signature, the public key, and then return is valid, question mark, true. So it also supports some of the examples that you might see at like OpenAI whenever you're trying to figure out how to do some like in-context learning, or say you want to do function calling. So this is an example straight from OpenAI where you can get the local location of what you're asking the prompt by saying, like, in this case, I said, what in Austin, Texas, what is the weather like, and what are some nice activities to do? And based on that, it gave me a list of actual things that are around Austin, Texas, and being able to do this if you are interested in finding some ideas to do around Austin. Understanding images. So TeddyDAO, I helped build TeddyDAO from the smart contract perspective. If you know Kenji out there, he built out the front end, and then KBL ran all of the product, and then Funky is the community leader. So essentially here, I took the banner from TeddyDAO, and I said, analyze this image, and it comes out and is able to then describe what's in the image. So using just simple GPT-4o and doing this, I did this in like minutes. Like it's like literally so quick to start building these templates, these AI agent contracts. Now here's our use case for Agent Wars. So in this case, this is Donald Trump. I start entering some prompts here. I get some answers based on how he tweets, which could be crazy, could be not, depending on what your perspective is. And then from there, you can see on the bottom left, there is the ability to trade and buy these keys. And as you can see here, we've onboarded about 2,045 key purchases for the multiple agents that have been claimed or been generated on our platform. But this is just more of a proof of concept that we're trying to figure out as we start to create different monetization efforts for these agents. And then also we want to get more feedback from developers so that whenever we're creating this Agent DAO template, we are not doing something too opinionated, and we're allowing developers to have a lot of flexibility to build out custom logic however they would like. So yeah, I've described some templates, but does anyone even build on it, right? So let's do some proof. So this last week, July 5th to the 7th, there was the DAGI Hacker House, and it was a couple of intense days, but we presented our technology, and to our surprise, we had 10 teams use our project. So the first one was social chain AI. That I'm just going to highlight a few of them. But this was a social engineering white hat agent that used Agent Wars API to here, at the bottom, you can see it's generating a text that we're going to use to use some social engineering techniques to post into a Telegram and say there's an airdrop, and then have some of the participants fill in the form. And it's just like a little proof of concept, but here's my real Telegram. You can see it says #warlock, and then the fake Telegram, it says #warlock, but if you look closely in your IDE and you look at the text editor, you can see that the L and the capital I are not very easy distinguished when it comes to Telegram. So what we did, we posted it here in the chat for the DAGI group. And then after that, we can see we hit all their, we didn't track any like data, but we just showed that we got about 20% of the participants to fall for this little social engineering. And the developer also had presented this idea at the very beginning when we pitched the idea, and nobody really took it seriously, and see how it ended up working out. Now, the next one is Mygorithms. This is build and choose your own Web3 social algorithms for your app. So this person had built a little agent that's going to rank based on the likes.
they create an interface where it's they insert it, and then they put the link to their agent right here, and then they add their algorithm, and then it updates here, as you can see, with the likes being in order based on how many likes you've gotten. The next one was DevDoc. So now we're starting to say like, oh, well, what's a Web 2 use case? Like, builders probably don't want to do a fully Web 3 solution, but this makes it possible to have an IDE extension with AI such that you can create some crypto rewards. So here you have your extension installed on Visual Code. You open, you sign in like a traditional one, and here now you're in. So now the first prompt, it's at the bottom left. It's hard to see, but it says, I need an NFT minting contract for Optimism. So what happens is it gives you some feedback, it gives you some code, and then you say, oh, this is great. I'm going to put this code here. It works. And then you say, I want to update it a little bit. And that's great. You update it a little bit. This code compiles. Now you want to do a commit, and you push that so that this updated code can get analyzed and see if there's a difference that's meaningful, such that whenever you deploy it after you're compiling here, you'll earn some tokens. So now you're starting to find another avenue, another interface to entice traditional Web 2 developers into crypto naturally. And they don't even have to like use the crypto. It's just like a little reward. But if you have a good product behind it, that can speak words for some of the traditional developers that may be put off by crypto. Next one is Jarvis. So if you think like intent-based trading or any kind of collaborative like multi-agent system, this agent is a multi-agent system that is token gated with the Jarvis NFT token, and you're able to use PHALA as a coprocessor to connect to these special models from Embed, Brian AI, and Pond as well to get some predictions on the market. So we can just kind of walk through the process. You create your multi-agent system. You choose your multiple agents here. You create it. And now you sign a transaction to create your agent. And let's start interacting with the agent. So you have these examples that you can use here. Next, we go, give me a prediction on Wrap Bitcoin. Great. Wrap Bitcoin token is predicted to move by negative $889 in USD in the next hour. Cool. Well, I want to swap 0.001 ETH for as much link on base. Great. Transaction pops up, you sign, and you do your swap. Next, we get some sentiment on link going up, and this is based on, in this case, it's like based on all the data on Farcaster that Embed's model is trained on. So here you can get like a negative sentiment percentage along with your neutral, positive, and now you're starting to see like these applications that really are hard to do, but now they're possible. And then finally, the first place winner was Warp Ads, so bringing Facebook ads to Web3 Social. Now, in this interface, you sign in, you go to buy an ad, you just give a title, you give a description, a logo URL, and then it's gonna call Embed's API that's gonna generate the top 5 labels based on your title and description. And here, you can see the 5 labels that are generated, and you can even verify that by running it directly through like some curl requests. And in this case here, we also added the AI agent contracts that do the PHALA oracles, so that here you can see that we created the ad here, and that's coming from the PHALA oracle. And then next we say, oh, I want to claim my royalty as an author of this ad. And then you hit claim, the royalty request is added to the chain, and then next we have the transaction on chain from the PHALA oracle to be able to get your rewards received. So that one ended up winning first place, and this is a sample of how the ad would look in Warpcast, because you can do these things called frames, and at the bottom you see the little ad, and then also the image that's part of the ad, and then whenever you want to enter that frame, this would be the expectation of what the real frame is actually built. But the LLMs do not run in TE. Sound centralized. I have like 2 minutes left. I'm gonna try to get through this, but AI right now is centralized. Equal access, so like why not centralized AI? Well, equal access to everybody. We already starting to see like GPUs being like restricted for other countries, people potentially not getting access to these models, and then the attention economic driven by a black box of malicious AI may end up dominating the area that you are. And there's just a lot of things that are unpredictable and that could happen. So we have a self-enhancing loop where we don't own any of this. Like the company owns all the data, the private AI is the most popular, and all the users are going to use it. And it's going to keep going and going until we get a better decentralized AI, like a global model that we could train. Next, we want to also allow that probably a path forward is users can provide their data, companies can provide their private data, and there has to be some kind of confidentiality there to be able to train these models so that it can become the best model, and then a majority of the users will use it. And how do we do that? We have to create some kind of verifiability for them to claim these rewards, claim these, be able to bring it back to the users. And if we kind of look at this breakdown for the loop, we have this verifiability and confidentiality supply chain that needs to happen to be able to make this possible. And this is something that we've already proven with the GPU TE for confidential computing on for these models. So what we proved out, I have like about 45 seconds left, but the TE-ML that I mentioned earlier, we have the input, we can get a remote attestation of the GPU TE, we can measure it with the CPU TE here in this chain of trust model, we can measure that attestation, and then from there, we can then verify on-chain of the output from the agent. So this is just like a little like, I'm glad you're here, sure, brother, because the GPU TE, you're gonna have to really trust NVIDIA, but it's the best we got. So 15 seconds left, verifiable ML. We have the remote attestation payload here. We load that into their interface right here where we have the post request, GPU. We have this, we get back EAT. And then for the example here, what we did was, hey, what's your name? We get a signature, and then we go on-chain and verify that this prompt came from the TE that measured the attestation from the GPU TE. One more thing, red pill that I mentioned, you should be able to choose your what you prioritize best with these LLMs that you're working with, and from there, we are building a LLM router network. You can check this out. Thank you, everybody. I think I'm out of time. Oh, I have 5 minutes more?
Yeah.
Oh, okay.
Thank you, Joshua. People, some question? Right. While people is thinking what to think, I would like to ask you and to the entire team of PHALA, how do you do for always be thinking in that kind of innovation? Because it appears like you are always one phase in advance with other products.
Oh yeah. For us, that starts with like really good design first as like core principles, and then next it's product market fit. So trying to find where your product fits in this industry, because when you're doing secure off-chain computation, it's really hard to convince people that they need it.
Yeah.
And that parallel where we found like this vector where AI was coming in and starting to simplify all the hard things that people are trying to build, we realized like this is kind of like the effort we had to really dive in full time. And this is like an effort that we started at the beginning of the year. So we advanced really fast. We have a clear idea. And if the developers want it, we're going to build it. And hopefully developers are going to start building on this product over the next few hackathons at ETH Global that we're going to sponsor. And we're going to get some meaningful feedback so that we can build the best product possible and the experience that the developers need.
All right. And now thinking about documentation process, because it's a new product, definitely. Is it possible to find information in the website, in documents, or what? How is the process to contact?
Oh yeah, so if you see here, docs.phala.network, you can check out our docs. I've built a ton of templates just based off that hackathon. If you have a model you want to connect to, or you have any ideas that you want added,
just reach out to me at @Warlock on Twitter or on Discord, and I'll get you set up. I'll walk you through it, and then you can give me some feedback so I can make sure that documentation and our technical ambassador program is running very smoothly and can be at the best quality it could possibly be. So I'm really looking forward to talking to all the developers and seeing how we can enhance this product.
All right. Thank you so much. Joshua, applauses, please.